The telegram arrived at the Admiralty on the afternoon of the 15th of February, 1966, and its contents would reshape British naval aviation for the remainder of the 20th century. Defence Secretary Denis Healey had signed the order cancelling CVA-01, the proposed 53,000-ton fleet carrier that the Royal Navy had spent the better part of a decade designing. The vessel, intended to replace HMS Victorious and HMS Eagle, would never be laid down at the John Brown shipyards on the Clyde. With one stroke of a Whitehall pen, Britain abandoned the construction of fixed-wing strike carriers, and the Fleet Air Arm found itself with a fleet of ageing platforms and no clear successor. The decision had been months in the making. Treasury figures circulated within the Cabinet Office in late 1965 suggested the carrier programme would consume nearly £1,400 million across its operational life, a sum the Wilson government considered untenable. The OR 356 requirement, which had specified a new domestic supersonic naval fighter, was likewise terminated. The Hawker P.eleven-fifty-four, an advanced vertical takeoff design that had progressed through multiple wind tunnel iterations at Farnborough, was abandoned outright. Britain's aerospace industry, which had once produced the Hunter, the Lightning, and the Buccaneer in rapid succession, found itself stripped of the very projects that justified its existence. Yet the Royal Navy still possessed 3 operational carriers, and these vessels required modern fighters. HMS Ark Royal, HMS Eagle, and HMS Hermes were equipped with the Sea Vixen, a twin-boom subsonic interceptor that had entered service in 1959 and was, by the mid-60s, hopelessly outclassed by Soviet maritime strike aircraft. The Tupolev Tu-16 Badger and the newer Tu-22 Blinder could carry standoff missiles capable of engaging carrier groups from beyond the Sea Vixen's effective intercept radius. The first Sea Lord, Admiral Sir Varel Begg, made the position plain in a memorandum to the Defence Council dated the 23rd of March, 1966. Without a supersonic interceptor capable of operating from existing carriers, the Fleet Air Arm could not meaningfully contribute to NATO maritime defence in the North Atlantic or the Mediterranean. Attention turned, reluctantly, across the Atlantic. The McDonnell F-4 Phantom II had entered United States Navy service in 1961 and had already established itself as the most capable carrier-borne fighter in the known world. Its twin-engine configuration, 2-man crew, and powerful AirNat PQ-72 radar made it ideal for fleet air defence. The Royal Navy's interest was practical rather than enthusiastic. Buying American went against every instinct nurtured at the Air Ministry since the Brabazon Committee of 1943, which had explicitly committed Britain to indigenous aerospace development. But the alternative was no fighter at all. Negotiations between the Ministry of Aviation and the Pentagon began in the spring of 1964, even before CVA-01's formal cancellation. Sir Solly Zuckerman, then Chief Scientific Advisor, attended several preliminary meetings at the Old War Office building on Horse Guards Avenue. The Americans were willing to sell, but Whitehall imposed a condition that would define the entire programme. If Britain was to purchase a foreign aircraft, then a substantial portion of its construction, and crucially its power plant, would be British. The Treasury insisted on offset arrangements, the trade unions demanded work for British factories, and the Royal Aircraft Establishment at Farnborough quietly insisted that any American airframe entering British service would need to be re-engined with a Rolls-Royce product. This was not mere protectionism. The Air Ministry's technical staff had genuine reservations about the General Electric J79, the turbojet that powered every Phantom then flying. Those reservations would soon prove well-founded. The General Electric J79 was, by any reasonable measure, an exceptional engine. First run on a test stand at Evandale, Ohio, in June 1954, it had powered the Convair B-58 Hustler, the Lockheed F-104 Starfighter, and now the Phantom. By the mid-60s, more than 10,000 examples had been built, and it remained in continuous production. The J79 GE-8 variant, fitted to United States Navy Phantoms, produced approximately 10,900 pounds of dry thrust, rising to 17,000 pounds with full afterburner engaged. For an American carrier launching from a steam catapult on a Forrestal-class supercarrier with 300 feet of run, this was entirely sufficient. Britain, however, did not operate Forrestal-class carriers. HMS Ark Royal displaced 50,000 tons fully loaded, considerably less than the 75,000 tons of her American contemporaries. Her flight deck measured 800 feet in length, and her BS-5 steam catapults, though recently modernised during the 1967 refit at Devonport, could deliver only 70% of the launch energy available aboard USS Forrestal. The mathematical reality was stark. A Phantom configured with 4 Sparrow missiles, 2 drop tanks, and a full internal fuel load weighed approximately 54,000 pounds. To launch such an aircraft from a British deck in tropical conditions, with reduced wind over the bow, required either a lighter aircraft or a more powerful engine. The Royal Aircraft Establishment at Farnborough conducted extensive performance modelling throughout the autumn of 1964. The findings presented in RAE Technical Memorandum Aero 9821 were unambiguous. A J79 powered Phantom would, in worst-case launch conditions from HMS Ark Royal, possess insufficient single-engine climb performance to recover safely from a catapult failure. The margin was measured in tens of feet per second, and it was the wrong side of acceptable. The Director of Naval Aircraft Development, writing to the First Sea Lord on the 11th of November, noted that operating the standard Phantom from British decks would constitute an unacceptable risk to aircrew under combat loading. There were further considerations beyond raw thrust. The J79 was a pure turbojet, a single-spool design, with 17-stage axial compression. Its specific fuel consumption was high, particularly at the subsonic cruise speeds, where carrier patrol missions spent the majority of their time. A Royal Navy Phantom flying combat air patrol 200 miles from its parent carrier would burn through internal fuel at a rate that limited loiter time to approximately 90 minutes. American operational doctrine accepted this limitation, relying on extensive aerial refueling support from Ka-3 Sky Warrior tankers. The Royal Navy possessed no such tanker fleet. Buccaneer S Mark II aircraft could be configured with refueling pods, but their numbers were limited, and tanker availability could not be guaranteed for every patrol cycle. The Air Ministry also harboured concerns about industrial dependency. To purchase an aircraft powered exclusively by an American engine would mean that every operational hour, every spare part, every overhaul cycle for 2 decades would route through Evandale, Ohio. Spare engines, hot section rebuilds, and turbine blade replacements would all require American licensing and American supply chains. In the event of a diplomatic dispute, or even a routine production bottleneck at General Electric, Royal Navy, and Royal Air Force operational readiness, could be held hostage to circumstances entirely beyond British control. These 3 factors, the launch performance deficit aboard British carriers, the fuel economy concern for extended patrol operations, and the strategic dependency upon American industry, formed the technical case for re-engineering. The political case had already been made. What remained was the question of which British engine could possibly fit inside an airframe designed around a quite different power plant. The answer, as it transpired, lay at Derby. The Rolls-Royce Spey had not been designed for combat. It had been designed, in the late 1950s, to power the de Havilland Trident, a 3-engined short-haul airliner intended for British European Airways. The original specification, drafted at Hucknall in 1959, called for a bypass turbofan producing approximately 10,000 pounds of thrust at sea level, optimised for the fuel economy and reliability demands of commercial aviation. The first Spey ran on a test bed at Derby in December 1960, and the engine entered airline service aboard the Trident I in April 1964. By any measure, it was a successful civilian product. The military possibilities became apparent almost immediately. Rolls-Royce engineers, particularly the design team led by Adrian Lombard, recognised that the Spey's twin-spool configuration and modest bypass ratio made it suitable for adaptation to military use. The bypass ratio of approximately 0.7 to 1 offered substantial fuel economy improvements over a pure turbojet without sacrificing the high exhaust velocities required for supersonic flight. A reheat system could be added to the bypass duct, providing the thrust augmentation necessary for combat manoeuvring and catapult launches. The engine's fundamental architecture was sound. What it required was militarization. The first military application was the Blackburn Buccaneer S Mark II, which entered Royal Navy service in 1965, powered by the Spey Mark 101. This variant produced approximately 11,000 pounds of dry thrust without reheat, and its introduction transformed the Buccaneer from an underpowered strike aircraft into one of the most capable low-level platforms in NATO service. The lessons learned from this program, particularly regarding the integration of an axial flow turbofan into a maritime strike airframe, fed directly into the Phantom program. Rolls-Royce had by 1965 accumulated more practical experience marrying high-bypass military turbofans to airframes than any other engine manufacturer in the Western world. The Spey variant proposed for the Phantom, designated the Mark 202 and 203 for the production aircraft, represented a substantial development over the Buccaneer power plant. Reheat was added, increasing wet thrust to approximately 20,500 pounds per engine. This figure, it should be noted with care, exceeded the 17,000 pounds available from the J79 GE8 by a margin of roughly 20%. Dry thrust likewise improved, reaching 12,250 pounds. The Spey was, on paper, a more powerful engine than the American unit it would replace. The contract was signed on the 27th of February 1966 between the Ministry of Aviation and Rolls-Royce Limited, with associated agreements covering licensing of certain accessory components from General Electric. The total value of the engine programme was set at approximately £125 million, of which roughly 40% represented development costs. The programme was managed from Hucknall, with engine assembly conducted at Derby and component manufacture distributed across Bristol, Coventry and East Kilbride. Short Brothers in Belfast received subcontracts for certain accessory housings, a politically significant award given the economic conditions in Northern Ireland during this period. There was, however, a complication that no amount of engineering brilliance at Derby could resolve. The Spey was physically larger than the J79. Its diameter measured 43 inches at the compressor face, compared to the J79's 39 inches. Its overall length, including the reheat section, exceeded the American engine by nearly 18 inches. Bypass turbofans require substantially greater airflow than pure turbojets, which meant the Phantom's intakes would need enlargement. The airframe, in short, would have to be redesigned, and that redesign would not happen in Britain. It would happen at St. Louis, Missouri, at the McDonnell Aircraft Corporation, where engineers would soon receive a most unwelcome set of British drawings. The drawings arrived at Lambert Field, St. Louis, in the early summer of 1966. McDonnell engineers, who had spent the better part of a decade refining the Phantom airframe through successive variants from the F4A through to the F4J, found themselves confronted with a set of British requirements that effectively demanded a new aeroplane. The fuselage would need to be widened. The intake geometry would require complete redesign. The accessory drives, the engine mountings, the bay cooling arrangements, the fuel system feeds, even the structural keel members running beneath the engine bays would all need modification or replacement. David Lewis, then president of McDonnell, was reported in internal company correspondence to have described the project as the most extensive airframe modification we have ever undertaken for a foreign customer. The fundamental problem was airflow. The Spey, being a turbofan with substantial bypass mass flow, required approximately 20% more air at the intake than the J79. McDonnell's aerodynamicists, working from wind tunnel data generated at the company's St. Charles facility, calculated that the existing Phantom intake ramps could not deliver this volume without unacceptable pressure losses at high Mach numbers. The intakes were therefore enlarged, with the lower lip extended forward by approximately 6 inches and the variable ramp geometry redesigned to accommodate the new flow regime. The boundary layer splitter plates, which separated turbulent fuselage airflow from the clean air entering the compressors, were repositioned and enlarged. The rear fuselage required even more substantial modification. The Spey's reheat section was longer than the J79's afterburner, and its larger diameter meant the engine bay doors, the cooling air ducts, and the structural frames surrounding the engines all had to be redrawn. The titanium heat shields installed around the J79 reheat zone were replaced with stainless steel structures of greater thickness, accommodating the different thermal signature of the British engine. The exhaust nozzles themselves were of British manufacture, supplied by Rolls-Royce, and integrated into the McDonnell airframe through a complex interface specification that ran to several hundred pages. These modifications carried penalties. The enlarged intakes increased aerodynamic drag, particularly in the transonic regime between Mach 0.9 and Mach 1.2. The widened rear fuselage similarly contributed additional wave drag at supersonic speeds. McDonnell's flight test data, gathered during the YF-4K trials at Edwards Air Force Base in California from June 1966 onwards, indicated that the British Phantom's maximum level speed at altitude was approximately Mach 2.1, commodable standard American 1, compared to Mach 2.23 for the standard American variant. The aircraft was paradoxically slightly slower in pure dash performance, despite possessing more powerful engines. The drag penalty exceeded the thrust gain at the upper end of the flight envelope. The British designation system reflected the dual-service nature of the procurement. The Royal Navy variant became the Phantom FG, Mark I indicating fighter ground attack, with delivery to the Fleet Air Arm intended from late 1968. The Royal Air Force variant, ordered subsequently in 1967, was designated the Phantom FGR. Mark II, the additional letter denoting reconnaissance capability through provision for an under-fuselage sensor pod. Both variants shared the Spey power plant and the modified airframe, though they differed in certain avionics, cockpit instrumentation, and weapons fit. The first YF-4K flew on the 27th of June, 1966, in American hands at Lambert Field. By the time the production aircraft began arriving at RNAS Yeovilton and RAF Coningsby in 1968 and 1969, approximately 45% of the airframe, by component count, differed from the standard American Phantom. The result was an aircraft that was unmistakably a Phantom, yet equally unmistakably a British one. The performance data emerging from the trials at Boscombe Down throughout 1968 and 1969 told a complex story. The Aeroplane and Armament Experimental Establishment, which conducted the formal British acceptance trials, produced a comprehensive assessment of the Phantom Mark II against its American counterpart, and the findings did not lend themselves to simple summary. The Spey-powered aircraft was superior in some regimes, inferior in others, and the operational implications of these differences depended entirely on how the aircraft would actually be used. Where the British Phantom genuinely excelled was in low-altitude performance. The greater dry thrust of the Spey, combined with its superior fuel economy at subsonic speeds, gave the FG, Mark I and FGR. Mark II markedly better acceleration from sea level to 10,000 feet than any American Phantom variant. From a standing start at sea level, the British aircraft could reach Mach 0.9 approximately 15% faster than a J79-powered F4J. Climb performance below 20,000 feet was similarly improved, with the British Phantom reaching that altitude in approximately 1 minute and 40 seconds, compared to roughly 2 minutes for the American aircraft. For low-level interception of incoming maritime strike aircraft, this acceleration advantage was operationally significant. Range and endurance figures favoured the British variant by a substantial margin. The Spey's specific fuel consumption at cruise was approximately 20% better than the J79's, which translated directly into longer combat air patrols and greater operational radius. A Phantom FG, Mark I configured for fleet air defence with 4 Sparrow missiles, and 2 external tanks could maintain a combat air patrol station 250 miles from its parent carrier for approximately 2 hours, compared to perhaps 90 minutes for an equivalent American aircraft. For Royal Navy operations, where tanker support was limited and patrol distances over the North Atlantic could be considerable, this endurance margin was decisive. The high-altitude story was less flattering. Above 36,000 feet, the Spey's bypass ratio became a liability rather than an asset. The thinner air at altitude reduced the mass flow advantage that gave the engine its low-level performance, while the additional drag from the enlarged airframe imposed a constant penalty regardless of altitude. The British Phantom's service ceiling, measured at Boscombe Down in standard atmospheric conditions, was approximately 57,000 feet, against 60,000 feet for the American variant. Maximum sustained turn rates above 40,000 feet were similarly reduced, with the Spey-powered aircraft able to maintain approximately 3.6 G at 35,000 feet and Mach 0.9, compared to 4.1 G for an F4J in identical conditions. Weight was a further complication. The 2 Spey engines, with their larger compressor sections and reheat assemblies, weighed approximately 800 pounds more than the equivalent J79 installation. The modified airframe added several hundred additional pounds of structural weight. A Phantom FGR, Mark II empty, weighed approximately 31,000 pounds against 28,000 pounds for an F4J. This weight penalty, combined with the drag increment, meant that the British aircraft's transonic acceleration above the tropopause was actually inferior to the American variant, despite the greater installed thrust. The verdict reached by the Director of Operational Requirements at the Air Ministry, in a paper circulated within the Defence Council in October 1969, was characteristically measured. The British Phantom was described as superior for the specific roles for which the Royal Navy and Royal Air Force intended to employ it, namely low-altitude maritime interception and medium-altitude air defence over the North German plain. For high-altitude pursuit of strategic bombers, the American variant retained certain advantages. The 2 aircraft in operational reality were optimised for different missions. The first Phantom FG. Mark I landed on the deck of HMS Ark Royal on the 28th of June 1970. The aircraft, serial number XT872, was flown aboard by Lieutenant Commander Brian Davies of 892 Naval Air Squadron, the unit that would carry the Phantom into Royal Navy operational service. Ark Royal was at that point the only British carrier capable of operating the type. HMS Eagle, despite extensive modernisation proposals, was deemed too costly to upgrade for Phantom operations, and HMS Hermes had been earmarked for conversion to a commando carrier. The Fleet Air Arm's supersonic interceptor capability would therefore rest upon a single hull. 892 Squadron, commissioned at RNAS Yeovilton in March 1969, and conducted its initial deck qualifications aboard the American carrier USS Saratoga in the Mediterranean. During the spring of 1969, before British facilities were ready. This arrangement, brokered through bilateral agreements between the Admiralty and the United States Navy, allowed Royal Navy aircrew to gain catapult and arrested landing experience, whilst Ark Royal completed her Phantom-capable refit at Devonport Dockyard. The refit itself, which extended from 1967 through to 1970, included installation of the BS-5 Mark I steam catapults, strengthened arrestor gear capable of handling the heavier Phantom airframe, and modifications to the deck blast deflectors to accommodate the greater exhaust energy of the Spey engines. Operating the Phantom from Ark Royal proved more demanding than anticipated. The catapult launches, even with the strengthened British equipment, occurred at the absolute margins of acceptable performance. Aircrew accounts from the period, including those recorded in the squadron line books, now held at the Fleet Air Arm Museum at Yeovilton, describe launch sequences in which the aircraft would pitch up sharply on leaving the catapult, settle momentarily towards the sea, and only then begin a positive climb. The procedure required precise engine handling and faultless catapult timing. There was no margin for error and no tolerance for mechanical fault. The cycle of operations from Ark Royal followed established Royal Navy doctrine. A typical day at flying stations would commence with an alert pair of Phantoms held at 5-minute readiness on the catapults, ready to launch against any approaching maritime patrol aircraft. Soviet Tupolev Tu-95, their reconnaissance aircraft, routinely shadowed NATO carrier groups, and intercepting them at distance became the principal peacetime function of the carrier-borne Phantom. 892 Squadron's operational record book documents numerous such intercepts conducted during deployments to the North Atlantic, the Mediterranean, and the Indian Ocean between 1970 and 1978. The squadron's most significant deployment occurred during the autumn of 1972, when Ark Royal sailed for the Caribbean as part of a NATO exercise, and her Phantoms conducted air defense operations against simulated Soviet strike packages. The exercise reports, declassified and released to the National Archives at Kew in 2004, indicate that the Spey-powered aircraft demonstrated their endurance advantage decisively, whilst American Phantom squadrons operating from USS Independence required tanker support for sustained patrol cycles. The British aircraft maintained their stations on internal fuel alone. The Royal Navy's Phantom era, however, was always destined to be brief. Ark Royal's planned decommissioning, set for 1978 under the 1966 Defence Review, was not extended. On the 27th of November of that year, the carrier conducted her final fixed-wing operations off the coast of Virginia. 892 Squadron disbanded on the 15th of December, and the surviving FG Mark I airframes were transferred to the Royal Air Force, where they would serve alongside the FGR. Mark II for another decade, the Royal Air Force had ordered the Phantom for an entirely different purpose. Where the Royal Navy required a fleet defender, the Air Staff required a strike aircraft and tactical fighter to replace the Hawker Hunter and the Gloucester Javelin in service across Royal Air Force Germany and at home. The initial requirement set out in Air Staff Target 356 in 1965 called for an aircraft capable of low-level nuclear strike against Warsaw Pact target conventional ground attack in support of the British Army of the Rhine, and tactical reconnaissance using the EMI sensor pod developed at Hayes. The Phantom FGR Mark II was procured to fulfill all three of these roles simultaneously. The first Royal Air Force Squadron to receive the type was No. 6 Squadron, which reformed at RAF Coningsby in Lincolnshire on the 7th of May, 1969. The station, which had operated Vulcan bombers throughout the early 60s, was extensively modified to support Phantom operations. Hardened aircraft shelters of the Type II design were constructed during 1968 and 1969, providing protection against the conventional munitions then assessed as the most likely Warsaw Pact strike weapons. The station's runway was strengthened and resurfaced, and dispersal facilities were established in accordance with NATO survivability standards. Number 43 Squadron formed at Leuchars in Fife on the 1st of September 1969, taking on the air defence role for Scotland and the northern approaches. 54 Squadron, also at Coningsby, became the principal ground attack unit. Number 2 Squadron at Larbruck in West Germany received its Phantoms in 1971, joining Number 41 Squadron and Number 31 Squadron in the tactical reconnaissance and strike roles. By 1973, the Royal Air Force operated approximately 170 Phantom FGR Mark II airframes across home and overseas commands, representing the most substantial single-type tactical force in the service since the Hunter establishment of the late 50s. The introduction of the Jaguar and the Buccaneer S Mark IIB in the early 70s progressively released Phantoms from the strike role, allowing the Royal Air Force to concentrate its FGR. Mark II fleet on air defence. By 1975, with the Soviet long-range aviation threat to the United Kingdom assessed as the principal aerial danger, the Phantom became the backbone of British air defence. The aircraft were redistributed accordingly. RAF Wattisham in Suffolk received 23 Squadron and 56 Squadron, defending the southern approaches. RAF Coningsby continued to host 29 Squadron. RAF Leuchars retained 43 Squadron, joined later by 111 Squadron. The German-based squadrons faced the Warsaw Pact directly. Royal Air Force Germany operated under 2nd Allied Tactical Air Force Command, and the Phantoms held quick reaction alert at 15-minute readiness, with armed aircraft cocked on standby in their hardened shelters. The threat was substantial. Soviet frontal aviation in East Germany, Poland, and Czechoslovakia maintained approximately 2,000 combat aircraft within strike range of the British sector. The MiG-23 Flogger, which entered Warsaw Pact service in numbers from 1973, was a particular concern. Royal Air Force intelligence assessments, drawing on signals intelligence gathered at GCHQ Cheltenham and from the listening stations at RAF Chicksands and RAF Digby, calculated that a Warsaw Pact air offensive could deliver several thousand combat sorties against NATO airfields within the first 48 hours of any conflict. Against this threat, the Phantom's Spey-powered acceleration and low-level performance came into their own. The aircraft was, by the standards of the mid-70s, a formidable interceptor, and it would remain in frontline Royal Air Force service until 1992, when the last airframes were finally retired from number 74 Squadron at Wattisham. The financial reckoning of the Spey Phantom programme remains contentious to this day. The original estimate, presented to the Cabinet by the Ministry of Aviation in February 1966, suggested a unit cost of approximately £1,200,000 per aircraft, including engines, avionics, and initial spares. By the time the final FGR, Mark II, was delivered in 1969, the actual unit cost had risen to approximately £3 million, 2.5 times the original projection. The total programme cost, set against the Public Accounts Committee assessment of 1973, came to approximately £540 million for 170 aircraft. By comparison, an equivalent fleet of standard F-4J Phantoms, purchased through foreign military sales, would have cost approximately £210 million. The cost overrun attracted sustained parliamentary criticism. Reginald Maudling, speaking from the opposition front bench during the defence, estimates debate of March 1969 characterised the programme as a textbook case of misplaced industrial sentiment overriding sound procurement practice. The Public Accounts Committee, in its 8th report of the 1970-71 session, was more measured but no less critical, noting that the desire to support the British aerospace industry had produced an aircraft that was, by every objective measure of cost-effectiveness, inferior value compared to the original American product. The space programme had cost approximately £300 million more than the J79 alternative would have done, and had delivered an aircraft that was slower at altitude, heavier, and more expensive to maintain. The defenders of the programme, led by the Society of British Aircraft Constructors, and supported by elements within the Air Ministry, advanced a different calculus. The Spey programme had sustained employment at Derby, Bristol, Coventry and Belfast through a period when the British aerospace industry was contracting sharply. Approximately 14,000 jobs were directly attributable to the engine programme alone, with perhaps double that figure dependent on the broader airframe modifications and avionics work undertaken in Britain. The export potential of the militarised Spey was likewise significant. The engine subsequently powered the Italian and Brazilian AMX strike aircraft, the Chinese Jian JH-7, and remained in production at Derby until the late 1990s. There were strategic considerations beyond the purely financial. The Spey Phantom programme had preserved British technical competence in military turbofan design, capability that would prove essential during the development of the RB 199 engine for the Panavia Tornado in the 1970s. Without the Spey experience, Rolls-Royce engineers would have approached the Tornado programme without recent military turbofan integration knowledge, and the timeline for the multi-role combat aircraft might have been substantially extended. The technical knowledge accumulated at Derby through the Phantom work fed directly into subsequent generations of British military propulsion. The operational legacy was equally substantial. The Phantom equipped the Royal Air Force Air Defence Force through the most dangerous decades of the Cold War, providing the United Kingdom Air Defence region with a credible interception capability against Soviet long-range aviation. From the establishment of Quick Reaction Alert in 1969 until the introduction of the Tornado F Mark III in 1986, the Spey-powered Phantom was the principal aircraft standing between Britain and the Soviet bomber force. Its endurance, its low-altitude performance, and its weapon system capability made it the right aircraft for the geography and the threat. Whether the programme represented good value remains a question without a single answer. It was, perhaps, the most British of all British defence procurements, expensive, controversial, technically remarkable, and ultimately effective at the task for which it was actually required.